In this lesson, we're going to continue on with that last unit we're dealing with, but we're going to look at the area today. So in our previous lesson, we talked about the perimeter and how that's the total amount around a shape, enclosing a shape. Now the area is what's inside a shape. So I could really count each of these individual boxes, but I'm not always going to have it on a graph. I'm not always going to have a nice shape that I could just count. So we would use the area formula, which most of us already know. For a rectangle, it's just length times width. So in this case, the length is 8 centimeters times 5 centimeters. And we multiply to get 40. But notice, I'm also multiplying the units. So I'm going to have centimeter times centimeter, so it becomes centimeters squared. Area is always in the units squared. We do need that, and that's a really important part to keep in mind. Okay, so the way the perimeter worked was just adding the same unit. So there was no multiplication to turn it into a square. We were just adding like terms. Okay, now you might have also heard this area formula referred to as base times height. That's also okay. And in fact, base times height is what's used for all parallelogram shapes. So that includes the rectangle, the rhombus, and the square. Now triangles, however, they are 1/2 base times height. Okay, and notice that the height always has to make a 90-degree angle. You don't want anything slanted here. So we got to make sure we get the right one. And we're going to see that in the next example here. So in exercise 1, we have a patio is to be made in the shape of an isosceles triangle as shown. Why would the calculation A equals 1/2 22 times 16 not result in the correct triangle? Well, just like I was talking to you about a second ago, the 22, if I look at it, that's not a height. The 22 is slanted, right? You're never going to get your height taken from a doctor when you're leaning. You always have to make your height a nice right angle. So 22 is not the height. So if we wanted to determine the area here, I need to draw in my height, and I'll use this right triangle like we've done in the past. So for this, just to find the height, I'm going to have 8 here because that 16's been cut in half by the altitude, and we will calculate x. So we have 2 sides of a right triangle, so we can use Pythagorean theorem first. Now, 22 is the hypotenuse, so we're going to have 8 squared plus x squared equal to 22 squared. It's 484. I subtract 64 from both sides. And I'm going to get the square root of 420. Now, it does say the nearest square foot, but remember what I've talked about in our previous lesson, I just don't want to round too soon. So me personally, when I'm finding the area, since its area equals 1/2 base times height, what I'm thinking I would do is I'm going to keep the base of the 16, and I'm going to just plug in the square root of 420 here just to make sure I don't make any silly mistakes of rounding too soon. I don't have to simplify or anything like that, but I'm just going to plug this all into my calculator like this now. So alpha y equals my 1/2 and the square root of 420. And now it said to round to the nearest square foot. So now I'm feeling okay with it to round it. Now, to make a nice even number, I look at the 3, but I'm rounding that number up because the 9 is 5 or greater. So I'm looking at 164 feet. So I could write squared feet out, or I could just do foot squared. Either one. Now, the patio is to be covered by stone that costs $12.25 per square foot. What would be the total? Notice it's in square feet as well. So you're taking that 164 and we're multiplying it by this $12.25 per square foot. So now I'm going to make sure that I do use the 164 because we rounded and we're basing that part off this. And it's going to be $2,009. Okay. If I keep going here, we have parallelogram ABCD, has the vertices given. So first thing I'm going to do, I'm only given A, B, and C, so I'm going to plot those ones first. So A is at 0, 6. B is at 9, 6. C is at 6, negative 2. So know these two sides right now. Now, remember, opposite sides in a parallelogram are congruent and parallel. So I'm just going to count here. The nice thing, I have AB. I'm going to count 9 from A to B. So it's just going to be 9 away from C to D. So D must fall there. Notice the slope's the same. I could have counted the slope from B to C and counted that amount from A, but we know here where D lies. So the vertex of D is at negative 2, negative 2. Now we want to show the area. Now, in this case, I already have the 9s, so I have my base. The height, though, since we have a graph, we can just utilize up and down here the height. So if I count that up, I have 1, 2, 3, 4, 5, 6, 7, 8. So since the area is equal to the base times the height, the base is 9, the height is 8, the area is 72. Now, there was no units mentioned. If you want to do units squared, you can because it's area, but you don't even have to include that. 72 would be fine here because there's no mention of units. Now, it asks us which side is longer, 9 or AB or BC. So we already have 9 here. If you want to be sure, though, use the 8 that we drew in. So that 8 that I drew in here, BC, I could do the same thing over here. And I can just do a quick distance formula to check, right? 8 squared plus 2 squared equals x squared. So I'm looking at 64 plus 4 equals x squared. 68 equals x squared. So I know this is going to become 8 and a decimal, but just to double check, square root of 68 is 8.24. So AB is bigger. You could have also done the distance formula to check, got the distance of BC because we had those points. Same idea, same concept. And that would have worked as well. Now the area of a circle is equal to pi r squared. So for this equation, notice it's giving me the circle equation again from the previous unit of circles. They give me the center and the radius, but I don't even care about the center in this case. I care about this radius squared. So area is pi r squared. Well, I already have r squared. So my area is 36 pi. And this originally was a multiple choice question. I lost the multiple choices, but I'm just going to leave it as 36 pi. It didn't tell me to round. It could have, but in this case, we're just going to kind of go with there was a little bit of a typo there. But I'm going to leave it in terms of pi for now. Exercise 4, a shape is constructed from a rectangle whose length is 10 inches and whose width is 8 inches long, with a semicircle attached at the end. What is the total area? So the first part, the area of the inside here, no problem, right? When I'm talking about the rectangle, we're just doing base times height. So inside here, we have 80 inches squared. Now, when I do the semicircle, the area of a circle is pi r squared. A semicircle cuts it in half, so I divide that by 2. Now, this side would also be 8, and that would be a diameter. So my radius would be 4. Now remember, you have to do PEMDAS, so I'd have to square that first. We would get 16 pi divided by 2. And I'm keeping it in terms of pi, so I'll have 8 pi here, 8 pi inches squared. And now the area is just getting that whole space inside, so I just add those two together for choice 3. Now, in exercise 5, we have a gallon of paint will approximately cover 450 square feet. An artist wants to paint the outside surface of a cube measuring 6 feet on each edge. Which is the least number of gallons of paint he must buy? So I need you to think about a cube for a second. Cube has equal sides, but we need to talk about how many equal sides it has. Okay, so in a cube, we have 6 sides that would have to be covered, but each of them have a square face. And since it told me that each edge is 12 feet. So first off, to get the area of that, we'd have 12 times 12. So the area of one of them is 144 feet squared. Now I could add that 6 times, or I could multiply by the 6 because each of the faces is going to be the same. So I'm going to have I just think I got cut off there, but 144 times 6 is 864. So now that's the total area that needs to be painted. What we need to determine here is if 1 gallon will cover approximately 450 square feet, we need to know the least number of gallons. So I'm going to divide this by 450 because that's the feet squared. We're trying to convert it into gallons here. So I'm going to divide that. And I get 1.92. And that means I'm going to at least need 2 gallons. Now, keep in mind, even if it was 1.3, I would still need 2 gallons because I'm painting a room or painting a cube. So I can't go less and not have enough, right? So if you don't have enough, you still have to go in and round up in that case. So you have to think about the context of a problem like that. You need to have enough paint to cover the room. You can't round down and just hope for the best. Part A on your own, because this is what we did in the last unit. So you should be okay. Pause the video here. So remember, I complete both sides to make, or both points to make completing the square. So we take that 2x, divide that b term by 2, and square it to get 1 that I add to both sides. With the y's, we add 4 to both sides. So my center should be -1, 2. Remember, you switch the sign there. And the radius was radical 17 because r squared was 17. But if I want the exact area of the circle, pi r squared, remember 17 is r squared. So area is just 17 pi. And in exact, we leave it in terms of pi. And that would be